Hi there, this is Vahid from VRF Education channel, and today in the third session of design pattern series we're going to get familiar with factory method. This pattern, also known as virtual constructor, and as the name implies, it's going to bring us another way to create objects in our application, the way that can lead us to loosely coupled classes instead of tightly coupled. This pattern is categorized under creational category, and it provides one of the best way to create an object. In traditional way, we need to know about the class that we need to create object from, and then use a new operator to create one instance from that class. But here, object created without exposing the creation logic to the client, and refer to newly created object using a common interface or an abstract class. Here, client knows about abstract class, but they are not knowing anything about the concrete subclasses. Okay, so we need to focus on interface or abstract classes in this pattern. And as I said before, this pattern is useful when we want to decouple the creation of an object from its implementation. So this is the first step to move toward loosely coupled classes. So what is the problem? Imagine that we want to create a logistic management application, and for the first version we are mainly focused on road transportation. So we have a class named truck, and a lot of code will be placed inside that class. And after a while, for the second version, we want to support sea transportation. So here we need to add another class inside our application named ship, and also add all of those logics inside the truck, this time to ship class. And the things get worse when we want to support another transportation system, for example air transportation. This time we need to duplicate our codes in three different places, and if something needs to change, we need to change them in all those three places. Here, factory method said that, okay, you should not be worried about the transportation system itself. You should just say, okay, give me one transportation system. I just want to deliver item over one of those systems that I currently support. Something like this. We have an interface named transport, and it just said, okay, every classes that want to inherit from me or implement me needs to override or implement this method, deliver method. Here, truck and ships inherit from this base class or this abstract class, and they implement their own deliver methods. And then when I want to work with the transportation system, I said, okay, give me a transport instance. Truck and ships both are transport instances, and then I just call deliver method, and I don't know this is ship or this is truck transportation. And this is the beauty of factory method. It says, okay, creation is my responsibility, and you just use this interface and work and do your works, do your jobs. There are two different types of implementation for factory method. The first one is something like this. We have a client code, and we also have a factory. Here we have three different shapes. These shapes implement an interface or inherit from a base class that the name is shape. It has a draw method. Okay, each one should implement its draw method based on their nature. For example, here we need to draw a circle, here we need to draw a square, and here we need to draw a rectangle. And then in the shape factory, we have a method named getShape. And one instance of this base class will be returned. So based on the parameter that we provide for this method, we get one of these concrete classes. These classes named concrete classes. And then in the main code, we ask for a shape from the shape factory. We are not going to create these concrete classes using new operator. We just call shape factory and get a shape from that, and then we can just call the draw method or the method or the operations that mentioned inside the base class. So this is the first implementation, and it's somehow used widely and more common than the other ones. The other structure is something like this. We have some concrete products that inherit from base class abstract classes named product. So the abstract class always named product, and here we have some concrete products 1, 2, 3, and etc. They all have implemented do stuff methods. And here we have another base class named creator. So for each product, we have a concrete creator. For example, concrete creator A, concrete creator B. These creator classes have a method named create product and return that product, that specific product that they created for. For example, here we create an instance of product A, and here we create an instance of product B. And then we have method named some operation here that will call the do stuff method of related concrete class. Okay, this is a little bit strange, but when we implemented it, you will completely understand the benefit of this structure also. So in this session, I'm going to focus on this structure, and in the next session, I'm going to cover this implementation for you. Okay, let's go and implement factoring method in practice. Okay, for factoring method, the first version, I want to implement this scenario. Imagine that I want to drive home and there's a couple of cars inside the parking lot. So I need to select one of them and drive home. First of all, let's add a new class named factory method client. This is where I need to run my application or my design pattern demo. And let's add it to factory method 1. I created a folder for this purpose, and yeah, this is a folder. I have 2 files inside this folder: factory method client, H file, and CPP file. And I need to model the cars inside the parking lot here. For example, here I'm going to add a class, for example, BMW, and then another one. Oops, I forgot to add it. Yeah, this is in the factory method. That's good. Another one, for example, Ford. And let's add another one, Honda. These are 3 cars available inside the parking lot, and I can use them. Let's also add a base class. For example, I'm going to tell it base car. Base car. I forgot to inherit all those concrete classes from this base class. Here in the base car, I'm going to create a virtual function, virtual void drive. It's a pure virtual function. So any class that inherits from this base car needs to implement these drive methods. And also let's go to the other classes and try to inherit from base car. Include the H file and also insert virtual drive. And I'm going to also implement drive inside the CPP file. Here I'm going to say qdebug BMW. Let's do the same for the others. For Ford, it's going to inherit from base car, insert virtual functions, and also implement drive. And here I'm going to use qdebug, qdebug Ford. And for the second one, again I'm going to inherit from base car, insert virtual functions, and add the implementation. And here add Honda to the output. So that's it. Now let's go to factory method client. Here inside the constructor, imagine I'm gonna simulate different parts of the application. Imagine I have two other methods named foo and the next one bar. These are somehow mimicking other part of the application that I want to use a car in my application. So here, imagine that I want to order a car from the parking lot management. What should I do without using factory method? So in the constructor, I have some code here, for example, and then some businesses, and then another code here. This code are somehow related to this part of application, foo and bar. I want to call them. So first, I need to create an instance of base car. It's a pointer to a base car instance, and let's bring the header file. So I'm going to use an if-else statement. Okay, I'm gonna say I have a car type. I'm going to order car based on a type. So it's not important right now, but I'm gonna check it. If the type equal to, for example, B, I want to instantiate the car instance with BMW. Okay, BMW, and that's a base car, so I can instantiate it. Also, let's bring QString new. Using here we use new operator directly, and then in the else section I'm going to again use if type equal to, for example, F. This time I'm gonna instantiate the car using Ford instance. And then after that I'm gonna call car.drive method. Okay, so variable call, let's also assign it to null ptr. That's it. So in the other part of the application, and also let's do a couple of checking here. If car not null ptr, then call drive method. Now in the other part of the application, I need to copy and paste this line of code, for example in the foo section and also in the bar section, and then here I need to call foo and bar. So everything is obvious when I create an instance of this client. I'm going to create an instance of a car. For example, here I'm looking for a BMW, here I'm looking for Ford, and in the bar method I'm looking for again BMW. Everything is just obvious. But imagine that now I had a Honda inside the parking lot, so I need to add an else if statement here, here and here to support hiring Honda from the parking lot. And it gets worse if we have more and more car inside the parking lot, or if we want to add a business logic inside this part of the application. Now let's run the application based on the thing that we had before. I changed the main window. If you watched the previous session, I created 3 different parts. So each session I'm going to add a button inside each group box. So let's go to a slot, click a slot for this one, and I'm gonna create an instance from this class. Client. And if I run the application and press the factory method, oops, something. Let's do what? Let's bring qdebug here so the others can just use it. Qdebug. Let's run the application one more time. Okay, everything is just fine. and run it. So if I press factory method, you can see BMW Ford BMW appeared in the console output. Now I want to change the way that I create instances of those cars inside my factory method client. Client is somehow misspelled. Let's correct it. Client. Yes. Yes to all. And this one, okay. And also let's rename this one to client. That's okay. So, and also this one change to, okay, that's okay. Let's build it. Okay, for this purpose we need to create a factory class. So I'm gonna create a class named car factory, and let's change the name. Here I'm gonna say I had a method that returns a base car instance, and the name is create car, and it's just accept type of the car as a parameter. Let's bring the H file here, and I'm gonna also mark it as a static member method, so we don't need to create instance from car factory. And yeah, that's okay. Let's implement this function. Here I need to just add this line of code and return what? Return car. And I don't need type here because I already get it inside the parameter list. And let's bring this one here. So let's get back to client code. Here we don't need to have these items, and I can really get rid of these creational codes. What I really need to do is to declare a variable named car equal to car factory dot, or I'm sorry, scope variable. Let's also car factory, bring it, create car, and the type is B. I'm looking for a BMW here, and then it's just need to copy and paste this line of code here and also here. Yeah, BMW. So the output is just the same as before because I just moved the logic for creation instance to car factory. So it's as you can see, BMW, Ford, and BMW. And if I want to add a new car support to my application, it's just necessary to get to this create car method and add the logic here. If type equal to H, I'm going to instantiate it using new Honda, and that's it. New Honda. Include the header files and get back to the client code. Here, instead of looking for BMW, I'm just looking for Honda. Let's run the application. And see the output. Okay, BMW, Ford, and Honda. So this is the first structure that we can use for factory method. We need to have a base abstract class or an interface that here I named it base car. In this class or interface, we need to declare the function that we need to have in common with the other concrete classes. Here we have drive. okay? And then we have some concrete classes such as Ford, Honda, and BMW. They all inherit from base car and implement that abstract function. And then we create a factory class and add a static method inside it. So inside the method, we just receive one parameter, the type. It is right now a string, or you can change it to an enum. And based on the input, we just create appropriate instance and return it back to the callee. And inside the client, I just need to call that function. For example, create car with the B as a parameter here, and here with the F parameter, and here with H parameter. And the appropriate car instance will be returned. And if I just press, if I just pass something irrelevant, for example, RR, to this create car, nothing will be returned. And because I checked for null PTR, nothing happened. I just have two output at the console. So this is it. This is the first way that you can use factory method inside your application. I hope you enjoyed the content, and I'll continue on next session with the other structure of factory method. Till next session, goodbye.